This is one type of surface hardening process for the flame hardening process. In this flame hardening process is mainly suitable for the carbon content of 0.3 percentage to 0.6 percentage of material is the around it is the medium carbon steel material. So in this material is rapid heating surface of steel or cast iron. Okay. So material heating is above the upper critical temperature using, so in this heating the material is above the upper critical temperature heating, so around maximum around 800 degrees Celsius. So the heating by using the oxyacetylene flame. Okay, the heating is done by the oxyacetylene flame. So in this process parallelly, okay, heating the parallelly the water spray. Okay, parallelly water spray causing to transform the austenite to martensite structure. Okay, the the heating போகுது. So parallel the cooling medium water spray. Okay வா. Okay, this is a heating process. Okay, this is a progressive method of flame hardening process. In this method is suitable for the medium carbon steel and cast iron material. Okay, this is not suitable for the low carbon steel material. Okay, this is not suitable low carbon steel material. Oh, in this low carbon steel material not it has not a sufficient carbon to convert the martensite. Okay, this material cannot have sufficient carbon to convert the transform to the martensite. So this is not suitable for low carbon steel material. So this in this method no alteration of chemical composition. Okay, in this chemical was not alteration, no diffusion of carbon or nitrogen in surface of material. So in this process no diffusion of any other materials, only for hardening. Okay, surface, only surface hardening process. Okay, so not diffusion of any other material. This method in the flame hardening method. Okay, so in the flame hardening method we have three types of spot hardening, progressive method and the spinning method. In this spot hardening process, okay, yes, a particular, okay, a particular region or spot on the component is heat by one or more flames. Okay, one or more flames and then quenched. Okay, in the progressive method heating and quenching devices are fitted in a single equipment. Okay, it is moved over the surface of the component. And the spinning method is the component are symmetrical or rotated and the flame is moved over the surface. Okay, the quenching, then after the heating the quenching is done by water bath. The maximum in this method the gas depth is 6 mm. The only medium carbon steel and cast iron is suitable for this process. Okay, so after the quenching we want to relieve the internal stresses of the, okay, to relieve the internal stresses from the surface of the material. So this internal stresses relieved by the tempering process. Okay, is low temperature tempering, so around 150 to 200 degrees Celsius. So in this process it has less scaling and decarbonization. Okay, so no other diffusion of carbon and nitrogen, so no less scaling and decarbonization. The heating and cooling is done by very fast. Okay, so the heating and cooling is very fast process. So it is so the core not affected, the inside of the core material is not affected. In this hair step this mainly depend on the gas pressure. Okay, rate of travel. Okay, rate of travel of flame head and component, distance between the component and flame, the chemical composition of the component, chemical composition of the component. Okay, the flame depth, case depth is depend on the gas pressure, rate of travel of flame or head or component, distance between the component and the flame, chemical composition of the component. Okay, is the flame hardening process. Thank you.